Good evening, sir.
Yeah, good evening, everyone. Just in 1 minute we are starting. Just give me 1 more minute, please.
Good evening, sir.
Yeah, good evening. Just 1 minute. Good morning. इधर कौन रखेगा?
Good evening, sir.
Okay, now we can start. So in the last class we started with bonding of carbon. We started that how can carbon form bonds with other elements, right? So we had seen that carbon has 4 electrons and 4 protons in its atom. Every carbon atom has 4 protons and 4 neutrons, 4 protons and 4 electrons. And depending on this, we discussed that carbon cannot form a bond by donating electrons. Carbon cannot donate its electron to any of the element. Okay. So can anyone give me or explain me why carbon cannot give to 4 electrons? Yeah, why carbon cannot donate 4 electrons? Yeah, good evening. Yes? Why can't anyone?
Good evening, sir.
Yeah, good evening. Can anyone answer why can't carbon form 4 bonds? Or why can't carbon donate 4 electrons? Yes. It is why can't. Yes, no one is able to remember. Oh my God. Dharya? Dharya?
Yes, sir.
Okay, why carbon cannot donate 4 electrons?
Why carbon cannot donate 4 electrons?
Yeah.
Uh, mm,
Shubhansh?
Maybe, sir, because like it will require a lot of energy, right?
Hmm. Okay.
I don't know, sir.
So it requires large amount of energy. Very good. However, you guessed it, but still you are correct. So it requires large amount of energy for all the 4 electrons to be removed. Okay. So therefore, carbon cannot form or carbon cannot donate 4 electrons. Then we had discussed one more thing. Why carbon can't gain 4 electrons? Yes, Shubhansh, why carbon cannot gain 4 electrons?
Sir, I was not attending the class for past few days, so I don't know.
Hmm. Okay. Sumuk, Sumuk, why carbon cannot gain 4 electrons? Moksha, yeah, Moksha, why carbon can't gain 4 electrons?
Sir, a carbon atom has 6 protons in it, and it is very small to handle that. If it gains 4 electrons, it is tough to handle 10 electrons in it.
Yeah, very good. So you write that it is difficult for carbon nucleus with 4 or it is difficult for carbon nucleus with 4 protons to hold 10 electrons. Okay, so sorry, it has not 4, it has 6 protons, right? So it's difficult for carbon with 6 protons to hold 10 electrons. Okay, due to their interelectronic repulsions will be greater. So that's why it's difficult. Then how does carbon form bonds then? We have seen the formation of carbon dioxide. We see the formation of methane. So how does carbon form bonds? See now, we have to start from here. How carbon form bonds? So the answer is that in these two types of cases, whatever we studied here, the bonds where we have formation of bonds by the transfer of electrons. For example, if we observe NaCl, so if you observe NaCl, NaCl is formed by the transfer of electrons. Okay. So here how NaCl is formed? NaCl is formed like sodium. It easily donates one electron and form Na plus. So sodium donates one electron and form Na plus ion. Chlorine is an electronegative element. So chlorine easily
Yeah, it's still silent.
Sir left the meeting, bro.
Huh?
Sir left the meeting.
Left the meeting.
Yeah, we know that, but without Savage is so silent. The whole meeting so silent.
sorry, my network was disconnected during this period. Let's continue again. Okay, so are you already now?
Yes, sir.
Yes, sir.
So see, sodium and chlorine atoms, they are held together because they can easily form ions. Sodium forms Na plus ion, chlorine forms chloride ion. So hence you have a ion like this, Na plus. So it's like this. They are locked or they are located with strong electrostatic forces of attraction. So suppose these are the sodium atoms and these sodium ions, they are held together by the strong electrostatic forces of chloride ion. So chloride ions which hold the sodium ions together in this way. Okay. So see, each sodium atom is bonded or attracted to each chlorine atom. Okay. So in this way, the strong electrostatic forces between sodium and chlorine, they are due to the transfer of electrons. And such a bond means force of attraction. Okay. So here, due to the strong forces of attraction between sodium and chlorine, such a bond is formed, which is by the transfer of electrons, and this bond is called as an ionic bond. The bond formed between the two ions is called as the ionic bond. Got it? So the bond formed between Na plus and Cl minus, that is an ionic bond. Then you can see the bond formed between, suppose I have NgCl2, or if I have NaF. Okay. So the bond formed between NaF is also ionic in nature because sodium donates its ion electron to fluorine and it forms Na plus and fluorine minus. So this is an ionic bond set up between sodium and fluorine. Wherever we observe the bond formation due to transfer of electrons. Okay. So that bond we call as the ionic bond. Got it. So see some other elements like even if you have Na2O. So Na2O, it is also formed by the transfer of electron from sodium to oxygen. Okay. So if I want to define here ionic bonds, see all of you need to pay attention in the class. Okay. I have tried everything like keeping your camera on, but it seems like you feel shy of. Why to feel shy of while keeping your camera on? If you have anything like camera not working or any other problem, that's a different matter. Okay. So if you want me to turn on the camera, I will keep my camera on also. Okay, then I think it should be on. See, ionic bond. Ionic bond, it is the bond formed due to transfer of electrons. So when the electrons are transferred from one element to another and ions are formed, then this type of bond is called as ionic bond. Yeah, very good, Siddharth. I like Siddharth has turned on his camera. It shows your presence, that you are present here in the class. So Dhriti, Meher, Rizwana, Yunija, you can also define your ionic bond to be as it is the bond between two ions. So the bond between two ions, it will be formed only when they transfer their electrons. So everyone understood about the ionic bonds?
Yes,
The
sir.
other way of bond formation, we call it as the covalent bond. See now how the covalent bond formation occurs. It is the bond formed by the sharing of electrons. So sharing of electrons generally occurs with such elements which are not able to donate their electrons also and not able to gain the electron. So generally those are the elements where the covalent bond is formed. So in the covalent bond, the electron which is being shared, it it compromises with both the elements. Okay, so we'll see how it works here. We'll see how the covalent bond works here. Okay, with carbon. So say like you have carbon. Now it has 4 electrons around it. So we'll be making here 4 electrons around the carbon, which we call as the electron dot structure of carbon. So when we represent the electrons with dots, okay. So when we represent these electrons, we are representing here only the outermost electrons of the element. Okay. So if I draw the electron dot structure of magnesium, so how many dots should I put up? Yeah, Meher, how many dots should we put up for magnesium? If I want to draw electron dot structure for magnesium,
Sir, sir, I don't know the ions of Mg.
so write down the electronic configuration of magnesium. Do you remember its atomic number?
Sir, I don't know.
Sir, I think we only take
Sir,
the
2, 8 and 2, 8,
Magnesium has atomic number 12.
282.
Okay, so it's 282. So how many? What should be the outermost electron here?
2.
2. So we will make here 2 electrons around magnesium. Now I can make these 2 electrons anywhere. It's my choice. I can make them like this, or I can even make them like this at single place. I can make the 2 dots here with Mg written here. So it depends on me where I want to make it. So around the name of the element, symbol of the element, anywhere I can make these electrons. So okay, now write the electronic configuration of write the electron dot structure of oxygen. All of you try to write down the electron dot structure of oxygen and
Sir,
nitrogen.
2 and 6.
Draw the electron dot structure. Generally, if the electrons are present in pairs, we represent 2 electrons at one point on one side. That's the general way. However, it's not necessary. For example, carbon I have written like this. I can write my carbon like this also. Carbon with 4 electrons. I can write this like this also. So this one is also correct. Okay, but we generally don't make 4 electrons on one side. I can write carbon like this also. Carbon with 3 dots. 1, 2, 3, and the other one on the other side. So this is also carbon. Okay. Now try to write, if I write down the electron dot structure of oxygen. So electron dot structure of oxygen would be, you will be making 6 electrons around oxygen. So 1, 2, you make a 3, 4, and I make a 5, 6. Okay. You can also do it like this. That's not incorrect. You can also make it like this. Oxygen O, and then make it like this. 1, 2, 3, 4, then 5 and 6. This one is also correct. Got it now? How
Yes,
many
sir.
electrons are there around nitrogen?
Sir, 7.
5. So how do we
5.
make it now? I can represent 2 electrons on the top. I can represent 3 electrons here. 1, 2, 3. Or I can represent nitrogen like this also. I can represent nitrogen with 5 electrons. So 2 here, 1 here, 1 here, 1. Sir. Yeah. Got it? Any other doubts? Now, can I expect you to write down the electron dot structure of different elements? Okay, now I'll be checking this. Try to write down the electron dot structure of aluminium, fluorine, phosphorus, sodium, and calcium. Write down the electron dot structures. Sulfur. Okay, I'm just waiting for your answers. I will check the answers through the camera now for everyone. Everyone will show me the answer for this.
Okay, sir.
So your question is, you need to write here write the electron dot structure of given elements. Okay, just okay. Now you will show me the answers for all these.
Sir, 1 minute, sir. Can you show again?
Okay. The elements are aluminium, iron, phosphorus, sodium, calcium, and sulfur. And at the same time, all of you will keep your camera on. All of you will show it at the same time. I'll be able to check all at the same time. Okay. Earlier I was checking one by one. I'll be checking everyone at the same time.
So the dot structure means that valence, no sir?
The dot structure means this one which we were doing here.
Sir, over, sir.
These ones which we were drawing.
Okay, sir.
Okay, this I'm talking about. You need to write down the electron dot structures of these. Also write for this also. I'm adding some more elements. You need to write for helium, hydrogen, silicon, fluorine, these elements. So you need to write down the electron dot structure of all these. Have you done?
So it's
Sir, phosphorus valency.
Which one? Phosphorus.
Yes, sir.
Its atomic number is 15.
Sir,
However, you should
valency
be
is
able
3
to
na
remember.
sir, phosphorus.
Yeah.
Valency is 3 na sir, phosphorus.
Valency we discuss later. You write down the valence electron around the element.
Sir, well, atomic number for sulfur is 16 na sir.
Atomic number for?
Sulfur.
Yeah, it's 16. Okay, I'm giving you the atomic number. I think some of you are facing issue with it. So you have 13, 9, 15, 11, 20. Sulfur is 16. Helium is 2. Hydrogen is 1. Silicon 14. Fluorine 17. Okay. So I think now I can check for everyone.
wait a minute.
Okay, those who have done can raise their hands. Can raise their hands. Those who have done can just raise their hands so that I know you have done. Okay, Siddharth has done. Very good, Siddharth. Okay. 4 people have done. Very good. So I see here 4 people. Fine. Siddharth, Ayonija, Sumuk have done. Okay. Rijwana also done. Abhinav, what about you? Abhinav, Aryan, Moksha.
Last one, sir.
Okay.
Still
Subhansh.
doing,
last
sir.
one.
Yeah, Subhansh.
Yes, sir.
Have you done?
No, sir.
So, which one are you doing? See, there is nothing new in it. Just the things, there is nothing related with the previous topic. We have done everything today on. I explained you the electron dot structure today, and that's what you have to make. Okay. In the electron dot structure, the valence electrons, they are represented around the element with dots.
Okay, sir.
So
Sir,
there
even
is,
I'm
okay. So I think this is one more one. Okay, okay, okay. Have we now done? Aryan, Moksha.
Sir, still doing, sir. Wait, sir. Please.
So Aryan, which one you are stuck with?
Sir, this sulfur, sir.
Which one?
Sulfur.
Sulfur. Okay. Write the valency of sulfur and then write. Okay, now just show me, then I will. Okay, now everyone can show. Just turn on your camera at once and show me. Whatever, how much, however you have done, whatever amount you have done. Even if you have done 3, 4, whatever you have done, just show. Okay, aluminium. No, there is fluorine is wrong. Phosphorus you haven't done. Calcium is wrong. Okay. Okay, Aryan. I saw yours. Okay, and Dhriti. Mm, it's not visible. Okay. Yeah, now it seems to be visible. You got, yeah. Yeah, it's correct. Some of them I can see. Okay. Okay, you can then say that. Yeah, say that. Sumuk, the class will end in 5 minutes. Yeah, say that. Abhinav, show your answer. Okay, see, I'm telling everyone the correct answer. This shows that some of the students, they are participating actively during the class. You have an active participation. It's not that just logging in. You have to be actively participating. So aluminium, it has 283. Now, so if I make the electron dot structure, aluminium will have 3 dots. So I can represent it 1, 2, 3. Okay. Then we have fluorine. So fluorine, it's 287. So fluorine will have 7 electrons around. I like fluorine with 7 electrons. So 1, 2, 3, 4, 5, 6, 7. Then I make phosphorus. So phosphorus has the valency 285. That's 15. So you write P with 5 electrons. So 1, 2, 3, 4, 5. Then you have sodium. So sodium is 281. So Na will have 1 electron now. Just Na, sodium. Then you have calcium. Okay, calcium, atomic number 20. It has the configuration 2882. It's not 2818. It's 2882. So calcium will be, can take 2 electrons just. So you can make either side. Even if you make on both the side, on one side, then also it's not incorrect. It's then also it's correct. Okay. So this is calcium. Then we obtain sulfur. So sulfur has 16. So it will be 286. So you will represent 6 electrons around sulfur. So you have 1, 2, 3, 4, and then you can write 5, 6. That makes it. Then after sulfur, you have helium. So helium is 2. So you just make 2 electrons. You can make either side or you make same side. It will be correct. This is helium. Next you have hydrogen. So hydrogen has just 1 electron. So hydrogen will be just H with 1 electron on it. Silicon will be 14. So it's 4 electrons. You have to represent 4, 1, 2, and you can make 3, 4. So this is silicon. Chlorine, there are 7 electrons. So you will write chlorine with 7 electrons. Cl and 7 electrons. So 1, 2, 3, 4, 5, 6, 7. Got it? Okay. Bye all of you. See you again in next class.
Thanks,
Bye.
sir. Bye,
Thank
sir.
you
Thank
and
you,
happy
sir.
learning.
Thank you, sir. Bye.
And thank you everyone for turning on your cameras.